Fs, and we're going to continue talking about database and storage systems in Google Cloud, right? So you remember that on yesterday we talked about cloud storage, and we talked about Cloud SQL and Cloud Spanner, the two managed relational databases, right? Today we're going to talk about the non-relational or NoSQL systems. We're going to talk about firestore and Bigtable. Now, they're quite different from one another, but what they have in common is that they do not use SQL, right? So when we talk about non-relational or no SQL systems, really the only thing they have in common actually is that they do not use SQL, right? And of course, later we're going to talk about BigQuery and memory store as well. BigQuery does use SQL, but of course it's a data warehouse rather than a database like Cloud SQL or Cloud Spanner. But let's talk about firestore first. Now, here we've got the list of the different types of NoSQL databases. So as we said, they're quite different from one another. Memory store is basically just a managed service for in-memory databases like Redis and Memcached. Firestore is what's called a document-oriented database, and by that we mean that we typically store the data in a hierarchical format in something like JSON objects. Again, they've got some examples there. Bigtable is, again, is a wide column data store where basically we have rows and columns, but basically they're for very large amounts of data. So unlike a relational database where we're joining tables, in a wide column store, we really just have very simple tabular data, as we'll see. Right, but let's talk about firestore first. And firestore is sometimes called a serverless database, which kind of sounds a little bit strange, but if you think about it, it's very similar to BigQuery, that if I want to go and add firestore to my data, if I want to add my data to a firestore database, if I just go into firestore in my project, I already have what's called a default database, but I don't need to provision any server like I did for Cloud SQL, and I don't need to provision any nodes like I did for Spanner, right? I can just, it's very similar to BigQuery. I can just go in and start adding my data. Now, the data that we're adding in firestore is called a collection, right? So basically, and firestore is an example of what we might call a schema flexible system, right? So what do we mean by schema flexible? Well, I guess we're probably more familiar with relational databases, which are called schema first system. So what we mean by that is we define a schema first. So we talked about what a schema was last week, the structure of the data, then we insert the data, right? So with a schema first system, like a relational database, this is what we do. But with a schema flexible system like firestore, we can define the schema while we are inserting the data. So we can do those things concurrently with one another. So that gives us great flexibility, as we will see, right? So let's look at how we would add some data. So let's say I want to store data about persons, right? So basically my collection would be a person, right? So again, I could just give, so let's just say persons, and a collection is a group of documents. So think of a collection as being like a table in a relational database, but and a document is like a row or an instance, right? So basically the first person that I'm going to create details about is Alice. So you'll notice that I'm defining the schema as I go. So the first field will be Alice. That'll be her name. And I'll add another field, which is her city, right? So again, notice I'm defining the schema as I go. These are the different types that are supported. But again, let's just say she lives in London, right? Okay, so then I can add a second person. So now I've got one person with Alice, but let's say I add a second person, which is Bob, right? So basically, if I add another person, so again we add a document here, and again we need a unique ID, and this person will be Bob. Now again, for Bob, I'm also going to have a name column, but I'm going to have a different schema. I'm not going to record Bob's city. I'm going to record his age instead, right? So again, maybe I'll give that a different type, like a number, and let's just say that value is 44, right? So basically, you can see that even though I had two documents in the same collection, the documents themselves have different schemas, right? So Alice has name and city, Bob has name and age, right? So this is what is meant by a schema flexible system, right? So if I tried to do that with a relational database, that would be crazy, right? Because in a relational database, all the rows have the same schema. But in a document or in a database, I can have slightly different schemas, right? So that can create a lot of flexibility when I need to adjust the schema for each document, right? And the other thing, as I said, that's characteristic about Firestore is that it is serverless, right? I don't need to provision any servers. I didn't need to size a database server or provision disk or anything. I can just go in and add my data, right? Very similar to BigQuery, as I said, but BigQuery, of course, is also serverless, but it's more of a data warehouse. This is more of a document-oriented database, right? Okay, and the other good thing about Firestore is it's extremely economical if I just have a small amount of data, because I don't need to provision a server, and basically I get 1 gig of data per month free. And even if I have a bit more than 1 gig, it's very economical because there's no server overhead, right? Now, indexes are created on every property. So think of property like a field, if you like. So I can have secondary indexes and so on. I can support ACID. So ACID just means I can do logical updates, similar to what I can do on a relational database. Of course, I do not use SQL, and I also can have either regional Firestore or multi-regional Firestore, right? So Firestore is like Spanner in that regard, that at the base configuration is regional, but I can have multi-regional if I want higher availability, right? So again, here's another example of a collection. So this time the collection is about famous computer people. So we've got Ada Lovelace as the first collection. The first document in the collection. The collection is users, right? And again, in this case, the Ada Lovelace document and Alan Turing document have the same structure, but they don't need to, right? So you'll see at the bottom here, I'm not sure if you can read it off the screen, but basically they're saying it's not quite true that Firestore is schemaless. I prefer the term schema flexible because you still have a schema, but it's just very flexible, right? But what they do say here is correct, that you have complete freedom over what fields you put in each document. So each document in a collection can have a different structure. Right? Now, of course, as I say, if you have completely different fields across documents, then it's going to be difficult to query the documents, right? Because if you want to query the documents on first name, they need to have a first name, right, in common, right? But it is very common to have slightly different schemas for each document. Right? Okay, and again, Firestore was often used with web-based applications that just required, relatively small amounts of data. Although it can have, you can store, terabytes of data in Firestore, but it's particularly economical for small databases that are very integrated with their web applications. Okay, so in this example here, they got this application where basically when they write out the updates, they write it out to Firestore. Now, you can also trigger a cloud function on a Firestore update, right? So imagine my application writes the database, but then I want a cloud function to be triggered by that update, which does some other kind of operations, right? So again, and you can check out the demo there if you want to. Right? Now, in terms of the programming experience, to query the data, we do not use SQL, right? So here they're showing an example of where I'm getting a reference to the collection of cities, and then I'm basically looking for where capitals begin with U, right? So again, the thing to note is that you do not use SQL to retrieve data from a Firestore database. Right? Okay, so that is the first of the NoSQL systems that we're going to look at. Now we're going to look at another NoSQL database called Bigtable. Right? Now, Bigtable is a big data product, and basically this is intended for where I might be wanting to store millions or even billions of rows of data, right? And it can support transaction volumes of thousands or even tens of thousands of IOPS per second. Now, and again, it can achieve that with very low latency, right? Now, you might say, well, what sort of applications could generate that amount of data? Well, think about something like an Internet of Things application, right? Where I've got embedded sensors in heavy machinery all around the world, and it's continually sending data via the sensors into the cloud and needs to be stored and analyzed, right? So if I have very high throughput and very low latency requirements and relatively simple data, Bigtable is a good choice, right? There's also a special use case for Bigtable, which is that it is API compatible with a very popular big data open source product called HBase, right? So if I have HBase applications on premises and I want to migrate those to the cloud, Bigtable is API compatible. But again, the thing about Bigtable is it can scale up to huge amounts of data, and again can support very low latency on the insert of that data. Okay, so when we create Bigtable, if we create a Bigtable, again, this is not serverless, because when we go into Bigtable, so let me just. So basically the first thing we have to do when we go into Bigtable is we have to create a cluster of nodes which will manage our Bigtable, right? So basically you'll see that it's asking me to create an instance. And so let's just say my Bigtable. And basically I just continue. And then I say, do I want SSD or HDD? And then they're saying, select a cluster ID, and a cluster is just a group of nodes, right? So again, I choose my region and my zone, and then I can allocate my number of nodes, right? So this is a little bit like Spanner, that the more performance that I want and the more data that I want to store, the more nodes I can allocate, right? And if I look at my advanced options, I also have the option to have a replicated cluster as well, right? So again, a little bit like Cloud SQL, which also supports replicas. Spanner also has replicas, but they're kind of automatically configured for you, right? So with Bigtable, you basically have to allocate a cluster, so it's not serverless, and then you need you need to create your Bigtable on that cluster instance, right? So here's some of the use cases for Bigtable. So as I said, Internet of Things is one that can generate a lot of data. Gaming, imagine I've got to analyze the click streams for multiplayer games all around the world. Similarly, retail, where I want to analyze click streams, maybe on e-commerce sites. So basically anywhere where I have a continual high volume stream of data that I've got to process quickly. Okay, so here's an example of a big table. So basically we have a table and we have columns, and typically we group the columns into what are called column families, right? So if columns are in the same family, that data is stored closely together, right? So you see here, I've got this column family flight information. What I can do there is I've got all these fields that relate to flights, and they're going to be grouped together. So when I go to read that information, I'll get all that information together. Right? Now, the other thing is I've got rows and columns, just like a table, but the only way I can access my data is via the row key, right? So in Bigtable, I only have one key, which basically uniquely identifies the row. I don't have secondary indexes or anything like that, right? So what I often have is I have these kind of compound keys, right? So you can see here that I've got a key which is maybe the destination airport, the arrival time, and so forth, right? And as I said, I can have many, many columns, or I can have many, many rows. But again, the base data structure is fairly simple. It's in this table format. Okay, so no questions on that. Okay, good. Oh, let's just delete his reminder. Okay, very good. Okay, and again, here they got an application. Macy's is a big retailer in the US, and effectively what they are doing is they're kind of analyzing all the price-related data that again is being generated by their stores, being fed into via PubSub into Dataflow. So Dataflow is kind of an ETL engine. It's extracting the information, writing it out to Bigtable. Right? So the thing that would be characteristic of this is I need to process millions of rows of data in a very low latency. Okay, now again, in terms of querying Bigtable, again, we do not use SQL, right? Because again, it's a NoSQL database. So in here, they've got the code where I'm talking about the instance ID, the table, and the column family, and then I'm just going to retrieve that data, right? So again, I do not use SQL. And here again I'm retrieving some information about pets, and here I'm just iterating through all the records. Okay, now the next one we're going to talk about